We spoke of synergy of VEEGUM and Van-Gel clays when used with organic gums. Back in the lab, we performed some exercises to demonstrate this to you. What is synergy? The American Heritage Dictionary defines synergy as the interaction of two or more agents or forces so that their combined effect is greater than the sum of their individual effects. We saw this slide in the main presentation. It charts greater viscosities being achieved by the combining of VEEGUM magnesium aluminum silicate with organic gums, such as carboxymethylcellulose or xanthan gum. The following video and slides will demonstrate this for you. First, you will see the achievement of viscosity with 0.75% sodium CMC. Next, you will see the achievement of viscosity with 2.25% VEEGUM granules. Lastly, you will see the achievement of viscosity by combining these two products at a 3:1 ratio. To prepare the sodium carboxymethylcellulose solution, 3.75 grams of sodium CMC were introduced into 496.25 grams of rapidly moving water and mixed until the gum was dissolved. When finished, the solution was poured off into a jar and allowed to sit for 5 minutes. With this material being pseudoplastic, a reading was taken 2 minutes after the viscometer had been started. The result of this exercise was 20 centipoise. To prepare the 2.25% colloidal suspension of VEEGUM granules, we placed 11.25 grams of the clay into 488.75 grams of distilled water. We hydrated according to recommendations. This was allowed to stand 5 minutes, and then the viscometer was started at 60 RPM. A reading was made 6 minutes later and recorded. The result of this exercise was 18 centipoise. The two materials were then combined. Prepared was a dry blend of the two thickeners in a 3:1 ratio. 11.25 grams of VEEGUM granules and 3.75 grams of sodium CMC were dry blended together and introduced into 485 grams of rapidly spinning water. This mix was hydrated according to recommendations. This was allowed to stand 5 minutes. The viscometer was started and a reading was made at 6 minutes. The result of this third exercise was 420 centipoise, very much higher than the two ingredients alone. You can see a graphic depiction of the response at the bottom of the slide. To this point, you have seen the viscosity results of the sodium CMC, the VEEGUM granules, and the combination of the two, but only as numbers. Now let's see what this actually looked like. Here you see 3 jars containing the suspensions we made. On the left is the 0.75% sodium carboxymethylcellulose and water, viscosity of 20 centipoise. The center jar contains 2.25% VEEGUM granules, viscosity of 18 centipoise. On the right is the 3:1 ratio suspension we made of the sodium CMC and the VEEGUM granules, the viscosity of 420 centipoise. Let's look at the jar that contains 0.75% sodium carboxymethylcellulose. Picking up the jar and swirling reveals a fluid liquid. Tipping it shows that the liquid has a low degree of viscosity but greater than water. Let's look at this again. Here you will see the flow of the 2.25% suspension of VEEGUM granules in water. Swirling the jar shows the suspension to be quite liquid. Tipping the jar over confirms this, noting that the flow is similar to the CMC. Let's see this again. This video is the 3-to-1 ratio of VEEGUM to CMC. Swirling the jar suggests the suspension is more viscous than the other two we have seen. Tipping it over confirms this, as the back and forth flow ceases rapidly. Let's see this again. We also did a side-by-side tipping of the combination jar and the jar containing VEEGUM alone. The left sample contains the VEEGUM alone and the right sample contains the combined products. The differences are very obvious. Let's see this again. Let us not forget yield value. The solutions you just saw were measured for yield value. The CMC provided no yield value, and you saw this demonstrated in the large presentation when CMC failed to suspend the silicon carbide. VEEGUM granules provided some yield value as expected, though to a minor extent. However, look at the yield value measured when the two materials were combined. Certainly the clay was potentiated by the CMC. In conclusion, individually, VEEGUM Evangel Smectite clays and organic gums such as sodium CMC or Van Zandt xanthan gum provide rheology. Together, the rheology and properties are greater. This allows formulators to fine-tune flow and yield value to their formula.